Hello everyone. In this section we will understand how to visualize our model in TensorBoard. So these are the topics we are going to cover. First we will discuss what is TensorBoard. After that we will discuss the overview of TensorBoard. In the last we will discuss how to create and train the model by using the TensorBoard. So first we will discuss what is TensorBoard. TensorBoard is basically a interface used to visualize the graph and other tools to understand, debug and optimize the model. It is a tool that provides calculation and visualization for machine learning workflow, and it also helps to track matrices like loss and accuracy, model graph visualization, project embedding at lower dimensional spaces. Now we will discuss the graph which we are going to use in the TensorBoard. In TensorFlow, all computations are represented as a schema of data flow. So every operations performs a mathematical operations on an input tensor to return another tensor. A graph simply shows the dependencies between the computations. In simple words, we can say that the data flow graph is a pictorial representation of the computations in a TensorFlow model that allows you to visualize how the computations are connected. A computations means a graph has node and an edge. The edge defines the tensor in the graph and the operations, while on the other hand, node defines the operations performed. Basically, node receives the combinations of input tensors and connects that node to another node. It is important to point out the computation graph that does not reveal the output of each operation, but it will also help to visualize how the operation is linked together. Now we will see the overview of TensorBoard. TensorBoard is used to inspect the flow of tensors in your TensorFlow model, and it will also optimize your model, and this function classify into two main parts. The first one is TensorBoard for graph visualization. The second one is TensorBoard for writing summaries to help visualize learning. TensorBoard for graph visualizations, TensorBoard for writing summaries to help visualize learning. So in this picture, as you can see, the panel of TensorBoard graph visualization. The panel contains different tabs which are linked to the level of information you add when you run the model. Now we will discuss briefly about this panel. The first one is scalars. It displays different useful details during the model training. The next one is graphs. Graphs is basically it displays the model, and the graph specifies the nodes and edges, while node take more tensors as input and generate a given tensor as an output. So basically the edge is denoted as a tensor and it will generate a new tensor, always depends on an individual operation. So if we are talking an example in TensorFlow, then the graph is the backbone of the example, and also we can say that graph is the combination of nodes that defines the operation in your model. So in TensorFlow, graphs are like a data structure that stores a set of TensorFlow operations objects that indicates the unit of computations, where object will be a tensor that specifies the unit of data. So in case of distributions, it shows the distribution of the weights, and histographs, it shows the weights with the histograph. So in time series, to visualize the word appending, we use the time series, and it displays the PCA, that is principal component and analysis. Basically this technique is used for dimensional reduction, and the reason behind of this technology TensorBoard is that a neural network can be something called a black box, that we require a tool to scan what's inside in this box. So also it understands the dependencies between operations, how the weights are calculates, and also it displays the loss function and much more other useful information. So when you will combine all the information together, you have a great tool to debug and find how to improve the model. Now we will understand how to create and train the model in TensorBoard. So before I create a model, I will remove all the logs which I have used in it by using this command. After that, you will check whether the TensorFlow has been installed in your system or not. Now to able to use the TensorBoard, we must load the first TensorBoard extension by using this command. After that, I will import all the required libraries like TensorFlow and datetime. Now I will load the dataset. For this, I am going to use the MNIST dataset by using tf.keras.dataset and then I load the train and test data as xtrain, ytrain, xtest, ytest. Since the input features are between 0 to 255, I will just normalize it dividing by 255. After that, I will create a new sequential. So after loading the dataset, I am going to create a new sequential model with a single drop out layer as model, that is tf.keras.model sequential. So in the first layer, I have created a flattened layer that will take the inputs image of shape, that is 28, 28. In the second layer, I have created a dense layer with 512 neurons and the activation function I am going to use, that is ReLU, and it is dropped out by the layer with the dropout rate, that is 0.2, and the final output layer has created a dense layer with 10 neurons and with the softmax activation function. So now I will display the summary by using model.summary. So as you can see that it displays the output shape, that is 784, 512 neurons and 10 output neurons. Now I will compile the model, call the fit on our data. I will just specify the path and the folder in which it should be saved. So in Windows, I have created a folder in local disk C named as the folder temp. After that, I have created two folders, TensorLog and the TensorLog. So this will place the logs in a timestamp subdirectory which we can use to access later. And now I will configure the TensorFlow as tf.keras.callbacks.tensorboard and the histogram value will be 1, which means I want the histogram computation for every epoch. Now to access that in the support interface, we have to use the command TensorFlow --log directory and the path name, and we have now the TensorBoard. As we can see the graph, and we have separate graphs accuracy in it for accuracy and loss. In our case, both training and the validation accuracy are increasing simultaneously. So with this, we have completed the TensorBoard visualization.